Okay, we're looking at section 1.2, exponents and radicals. These are the pre-class notes. Pretty much what that means is that these are background skills or easy skills that we want to go ahead and get out of the way before class time so that we can spend our time working on the more difficult material and giving you time to work in class. The objectives for today's video are to identify and evaluate exponential notation, to review properties of exponents, to review zero and negative exponents, and to simplify exponential expressions. Exponential notation is a way to write multiplication with a repeated variable in a shorthand format. So for us, what that means is that we want a way to write things like 3 times 3 times 3 times 3 times 3 times 3 in a shorthand format. The rule is the number that is being multiplied multiple times together becomes the base. How many times you repeat the multiplication becomes the exponent. So again, this is basic skills and filler skills for the class. So we have this 3 is being repeated 6 times. So that would be 3 to the 6th. Okay. Now, we're going to go over some general rules. First of all, let's talk about this is a to the first is a to the second is a times a, so we already discussed that. We can evaluate such expressions either by long format or doing the repeated multiplication, or we can use our calculators. Calculators would usually be the probably smart choice, especially if the powers are really large. So if you use your calculator, you're either looking for a button like this, we call that the hat, or some calculators will have like an X to a blank, that could be your exponent, or some might even have like X to the Y. Okay, so like if I wanted to type 3 to the 6th then on my calculator has the hat, I would type 3, the hat button, and then a 6, and then hit enter or evaluate equal sign, and it would tell me what the answer is. Make sure though, if you have parentheses involved in your problem, you know when you should or should not type them into your calculator. That's what we're going to look at in this first example here. I want to talk about when is it appropriate to use the parentheses in your calculator and when is it not. So we're going to express the numbers in the form a over b, where a and b are integers. Notice that this is negative 2 over 3 to the 4th power. So notice that the negative is inside the parentheses. When that happens, it is included as part of the thing that is being raised to the power. So if I wanted to write this in longhand, I would write negative 2/3 times negative 2/3 times negative 2/3 times a negative 2/3. So notice the negative has been written 4 times. And when we multiply that out, that makes a positive. And then we have 2 times 2 times 2 times 2, which is 16, over 3 times 3 times 3 times 3, which is 81. So this final answer would be 16 over 81 with a positive value overall. This is much different. Okay, this says we have a negative and then the 2/3 is being raised to the 4th power. This is like having a negative 1 out front and then multiplying by 4 2/3. Notice no negatives included inside here. So if you were typing this on your calculator, you would not put a negative inside of a parentheses. So this is still 16 over 81, but it's times a negative 1 out front, so that makes the overall answer negative 16 over 81. Okay, let's look at the next group. Again, this one, the negative 3 is being included in the part that's being cubed. So it's negative 3 times itself 3 times. 3 negatives when you're multiplying stays negative, and 3 times 3 is 9 times another 3 is 27. Okay, and then this one is again, notice there's no parentheses anywhere, but because the negative is not in a parentheses, this is really the case, -1 times 3 to the third. If it's not in the parentheses, the power does not apply to it. So this would be -1 times 3 times 3 times 3, which again ends up being -27. So something interesting to note here, in the first two, where you put the negative did impact the final answer because it was raised to an even power. So when you're dealing with even powers, that negative going in the right spot really does matter. When you're dealing with odds, so I have an odd power of 3 here, the answer is going to work out the same either way. So if you're careless there, it's not as big of a deal, but it's better to not be careless at all. Okay, let's look at some review of rules. So properties of exponents for real numbers a and b with integers n and m. We're going to look at some examples, and then I'm going to give you a general rule for these. You probably remember most of these, but it's good to review them again because we assume that you know this, but it's better to watch it and make sure that you really do know it. So if I have something like x to the third times x to the fourth. In shorthand, that's what we have. If you think about this as longhand, this is 3 x's for the first group, and then 4 x's for the second group, which is a total of 7 x's. Now we can get that a lot quicker if we realize that 3 plus 4 is 7. So when you have same base and you're multiplying them together, we add the exponents. So our general rule is a to the m times a to the n equals a to the m plus n. And again, the base has to be the same for the rule to even matter. The next rule that we have looks like this. X to the second power raised to, let's say, the third. Okay? We have x squared being cubed. If we want to write that out, that would be x squared times x squared times x squared. We would write it 3 times because we're cubing this. Then you see that it's an application of the first power that we just had. So 2 plus 2 plus 2 is 6 altogether. A quicker way to get there would be to realize that 2 times 3 is 6. So if you have a single base and 2 powers attached to that base back to back like that with parentheses, we multiply. So our general rule is a to the m raised to the nth power is a to the m times n. This next rule is just an application of a couple things that we've already learned. So say I have something like this, 2x squared y cubed all to the, let's say, third power. As long as this is multiplication inside here, we would hope that we can just cube each part. Now we want to see if that's actually true. So we're going to write it as the inside 3 times because that's what it means to cube. So notice I get 2 to the third power because there's 2 times 2 times 2. X squared times x squared times x squared, well that is 2 plus 2 plus 2. Or you could have noticed 2 times 3 if you'd noticed the power rule. So that would be 6 of those. And then y cubed times y cubed times y cubed is y to the 9th. Now if we work that out, that is 8x to the 6th, y to the 9th. So we can cube each individual piece, and then we have our final answer. So a generic rule for this is a times b to the nth power is a to the nth power times b to the nth power. Which brings us to our next rule, which is the power of a quotient. This is just the same idea, except now we're putting it into a fraction format. If we were to square that, I'm going to just go to the shorthand right away. This would be x squared squared over y cubed squared. You have the power rule twice. See, this is 2 powers on one base, so that would be multiplication. So this is x to the 4th, and this is 3 times 2, so y to the 6th. So if you have two separate bases, one on top and one on bottom, with a power on the outside, the power applies to both bases. Now notice, in both of these scenarios, I had no adding or subtracting going on. As soon as you put in adding or subtracting, this rule does not hold. So this is for multiplication of bases and division of bases. Something different in this next one is, what if your base on top is the same as the base on the bottom? So let's say x to the 5th over x squared. So if we think about writing that out, you have 5x's on top and 2x's on bottom. And anytime you have something over itself, when you're multiplying, it reduces to 1. So this just leaves me with x cubed. A quicker way to get there is to notice that that is 5 minus 2. It's subtraction of the powers. So a to the m over a to the n is a to the m minus n. I don't always do the subtraction rule. I just look at the powers and say, where do I have more? I have 3 more on top. So that sometimes gets you to get to the answer a little quicker. Now, the next thing is a special case, the 0 rule. So let's say 2x to the 0 power. Okay. This is understood to be 1, but I'm going to show you why it's 1. And I'm going to show you with a different example. X to the 5th over x to the 5th. If you subtract your powers, just like we learned in the last example, that gives you x to the 0. But x to the 5th over x to the 5th is 1 because it's the same thing on top and bottom. So therefore, anything to the 0 power has to be 1. So 2x to the 0 power is 1. So essentially, anything raised to the 0 power equals 1. And that's because of the quotient rule for exponents. The 0 exponent follows from that as a special case. Do be careful though, if you have something like 2x to the 0 like this, that is not just 1. That is a 2 times a 1. The difference between this one and this one is the 2 is in the parentheses here and not here. So do pay attention to your parentheses. And then the last of the rules for exponents is the negative exponent rule. So this happens when you have something like this. More x's on bottom than you do on top. If we do the subtraction rule, that's 3 minus 5, which is x to the negative 2. But if you notice, if you do canceling, you'd have no x's left on top and 2 x's left on bottom. So because this is the same thing as 1 over x squared, because that's just reducing the x's, we now have a rule that says 1 over x squared is the same thing as x to the negative 2. The way I like to think of this is anytime you have a negative exponent on something on a base, that means it's in the wrong position in the fraction. So it moves down if it's on top and becomes a positive. If it was on bottom and negative, it would move up and become positive. Now here's another thing people don't always talk about. If you have a positive exponent and you move that base, then that base would now have a negative exponent. It goes either way. So my general rule is a to the negative n is 1 over a to the n. Okay, let's talk about simplifying an exponential expression. To simplify an expression involving powers of real numbers means to change it to an expression in which each real number appears only once and all exponents are positive. And we're going to assume that the denominators always represent non-zero real numbers because you can't have 0 in a denominator. That is a domain error. So the remainder of this video is us just working through some examples that combine the rules that we've talked about. So let's look at A. Okay, this is no powers on the outside of either parentheses, so as long as that's true, you can go ahead and just multiply. So 3 times 4 would be 12. This is x3 times x to the first, so we would add our powers, so 3 plus 1 is 4. This is y4 times y5, so different, same bases being multiplied together, add the powers, and you get y to the 9th. This is a case where you have a power on the outside, so you can think of this as 2 to the 4th, a squared to the 4th, be cubed to the fourth and c to the first to the fourth. Work out each part. 2 to the fourth is 16. This is power on the same base, so that would be multiplication of powers, so that is a to the 8th. This is again power, so that's b to the 3 times 4 is 12. And 1 times 4, so that would be c to the 4th. Okay. Looking at this one, we have a problem here. You cannot just multiply across right now because you have powers on each of those parentheses on the outside. So you actually have to square everything first before you can, on the first one, and then cube everything on the second one so that you can figure out what the actual values are. So this would be what my first fraction would look like if I apply the power of 2. And then there's my second one if I apply the power of the 3. So 2 squared is 4. R to the 3 to the 2 would be multiplication of power, so that's R to the 6th. We have an S cubed on top, S squared on bottom, and then 3 times 3 would be R to the 9th. Now we're not finished with this problem because since this is all multiplication, you can reduce your fraction down. So let's change the color here. These 6 can be reduced with 6 of those, so that would just leave me with 3 in the bottom. And these 2 can be reduced with 2 of these, which would leave me with 1 s in the top. So my final answer would be 4 s to the first over r to the third once we have put it in reduced format. Okay. And our next one. Okay, now we've got some negative exponents in play. You could try to move the u to the -2 to the bottom first and then try to work with that, but you've also got a negative on the outside. My opinion is usually to save moving the negative stuff around till the end. Sometimes it'll go away. So I'm actually going to apply the -3 power to everything inside. And the reason that's nice is because when you do power on the first base, -2 times -3 is +6. But we do get 3 times -3 for v, so that would be -9. Because all answers in the final must be positive, we have to realize that the v is in the wrong location of the fraction. Once it moves to the denominator, the power is then positive. So v to the 6th, or excuse me, u to the 6th over v to the 9th. Okay, in this scenario, I might actually move some things around first because I've got negatives on top and bottom. So if I was to do that, 8 and x to the third are fine on the top because they both have positive exponents. 4 and y squared are okay on the bottom because they both had positive exponents. The x to the -1 would move to the top. The y to the -5 would move to the bottom. And now I'm just reducing and combining, oh, excuse me, this would be positive now. Reducing and combining like variables and reducing the numbers. So 8 divided by 4 is 2. We have 3 plus 1 for the x's on the top, so that would be x to the 4th. And 2 plus 5 more for the y's would be y to the 7th. Okay. Now, one more technique that you might want to try. If you see that everything inside is positive, or even if it's not, but the outside number is negative, if you're dealing with a fraction, one trick you can try is if you leave the exponents alone inside, but you flip everything. So in other words, we would say this is going to turn into the reciprocal fraction. Now, if any of these were negative exponents inside, you would leave them negative even if you flip them upside down because we're only taking care of this -3. So if I flip everything inside without changing any values, what that does is that says that I've flipped the entire fraction. So now that that happens, this -3 would become a +3. So that is one way you can try to get rid of that negative on the outside really quickly. Then I'm just cubing everything. So this is 2 to the third, v to the third, over u squared to the third. So that would be 8v to the third over u to the 2 times 3, which is 6. Okay, so that is the pre-class notes for section 1.2.